Good morning, students. So today we are going to discuss the another topic, that is properties of determinant, exercise 4.2. So let us learn. There are 6 properties, okay, which we will apply in the questions to get the results. So let's learn the properties. So property number first, it states that the value of determinant remains unchanged if its rows and columns are interchanged. I hope you got the point. We studied this thing in transpose of a matrix. So here what we are going to do, if rows and columns are interchanged, then the value of determinant remains same. Okay, so let us see through the example. It means determinant of A equals to determinant of A transpose, because while we find the transpose of matrix, right, transpose of matrix means we are interchanging rows into columns or columns into rows, so the value remains same. So let us prove this thing. Consider a determinant of a square matrix 1 2 3 4. So the value will be 1 into 4 minus 6 equal to minus 2, that is cross product. Okay, we yesterday learned about how to solve this order 2 determinant. Now if I change this R1 and R2, so here I am changing R1 and R2, so the rows are being interchanged. So let's find the values. 4 minus 6, so by interchanging the rows 1 2, here see rows 1 2 and 3 4, first row first column, second row second column. So what we find, the result will be same. Okay, so if any two rows or columns are interchanged, so first row changing into first column, second row changing into second column, so the value remains same. Okay, now let's see the second property. If any two rows or columns of a determinant are interchanged, so that time we were interchanging all the rows, but this time we are interchanging any two rows or two columns. Okay, so let's see the example. 1 2 3 4, value minus 2, as we calculated first, same example. Now this any two rows or any two columns, so what we are going to change, this is the row first and this is row second. Okay, so what we have done, see here this 3 4 has taken as row 1, so here is row second interchanged into row 1 3 4, and this row 1 interchanged with this second row, so the columns are interchanged. Or let's see the values. After simplifying we get the value 2, and here we are getting value minus 2. So what the property says, then sign of determinant changes. Here the value was minus 2, and after changing the two rows, right, mutually we are getting 2. So here is minus 2 and 2. So we clearly see the change in sign of the determinant. Here minus 2 and 2 is coming. So it happens if any two rows, like these two rows, are interchanged. Okay, and the same operation will be applied for order 3. Now next property number 3. If any two rows or columns of a determinant are identical means same, then the value of determinant becomes 0. So according to this property, if any two rows or any two columns are identical, that is same element, so then value becomes 0. So 1 2 1 2, same row is taken, so let us simplify. 2 minus 2 equals to 0. So hence we will say the row 1 and row 2 are identical. So whenever two rows or two columns are identical, then the value becomes 0. This is property number 3. Now let's see property number 4. If each element of a row or column multiplied by a constant, that is k, that is any row or any column is multiplied by any non-zero scalar, that is k, then its value gets multiplied by k. So let us understand this property through the example. Suppose this is the given determinant a1 b1 c1 and so on. and now we are here multiplying this row by k, k1, kb1, kc1. That is, row 1 is multiplied by the constant k. Then after simplifying this value, the value of this determinant is equal to the same. You can expand this and get the result. This will be equal to k times of the entire determinant. That is a1, b1, c1 and so on. So if you solve all the determinant, then you will get the same result, right? So remarks, due to this property we can take out any common factor from any rows. We can also say that here k is coming, so we have taken this k common from row first. It means by using this property we can take any number, any constant common. So this is a very important property in solving the questions, right? So now in the same property number 5, if sum of all elements, of a row or column of a determinant are expressed as the sum of 2 or more terms, then the determinant can also be expressed as the sum of 2 or more determinants. So according to this property, suppose this is the given determinant a1, b1, c1, okay, and plus lambda 1, lambda 2, lambda 3. So here we see that this row 1 is the sum of 2 terms. So according to property, if any row is a sum of 2 or more terms, there are 2 terms, there may be 2 or more terms, like plus lambda 3, lambda 4, something like that, right? So this determinant can be expressed in 2 or more determinants. So here are 2 terms, so we will express this in 2 determinant. How? See, first of all we will write first element. See, a1, a2, a3, a1, a2, a3, and the other rows elements are as it is, no change. Then plus, because plus is there, so lambda 1, lambda 2, lambda 3, lambda 1, 2 or 3, and the row 2 and row 3 there is no change at all. So what we are doing, the first row is being expanded into 2 forms by taking first element for the first determinant and for second element second determinant. If there are 3 elements, then we will have one more determinant. Okay, so this is also the important property. Now the last property 6. If to each element of any row or column, to each element of row or column of a determinant, the equimultiples of corresponding elements of other rows, equimultiples, that is equal multiples of any other rows or columns are added, then the value of determinant remains same. So what is the conclusion of these 4 lines? That any row, that is R1, can be expressed as R1, that is same row, plus we can multiply by the constant k to any other row, like R2 is there, and we can add into this. And you can recall this is the third property in elementary transformation, okay, what we studied in exercise 3.4 in matrix algebra. So it's like same. So here in determinant we can apply that property number 3rd over here. That is, any row Ri can be expressed as Ri plus Krj. So this is the same row, and this one is what? Any other row, and we are multiplying by k. K may be any number, any fractions, right? So these are 6 properties what we have learned, and now let us apply it to the question. So look at the question number 1. Question number 1 to 5, they are based upon these properties using the property of determinant. So question number first is taking xyz determinant is this one is given. So now we are using which property? See here, the column third is the sum of 2 terms, and we have learnt in property 5. Remember? Let's see this one. Here property number 5 says here is row, and in that question column is given. So what we have done, we can expand these terms into the various determinants, right? That we have expanded this determinant, first term and second term. So same as we will do the same property, that is property number, you can say using property 5 in this question. So the remaining rows or columns are as it is. So x, y, z, a, b, c both are as it is, and x, y, z we have taken first element of this determinant plus first and second column as it is, as we have done there also, and now a, b, c, the second element a, b, c is coming. So what we have done here, we have used property number 5 and expand the determinant, right, in two determinants. Now again there is also the property, if any two rows or columns are identical, identical means see the same elements are there in C1 and C3, so the value of determinants gets 0. Same as here, this column C2 and C3 both are identical, identical means same, so the value of determinant becomes 0. So 0 plus 0 equals to 0. So here we have also used the property. Okay. If any two rows are identical, then value becomes 0. Clear? So before solving the question, you must remember all the properties, right? Now let's do the question number 2. A minus B, B minus C, C minus A, so we have to use the property. Now we have to think there are 6 properties. So which property can be applied? So here nothing is same. I mean no two rows or two columns are identical, right? So we can expand the determinant, right? But that is somewhere lengthy. And now we are using property number 6, right? So you can see we are using here property number 6, R1 tends to R1 plus R2 plus R3, right? So let's apply this, or you can think about adding column. So the symbol of determinant. So if we write this R1, that is first row, as the sum of, we are adding all the rows, that is R1, R2 and R3. So if we add all these three, A minus B plus this, so we see A and A cancel, B and B cancel, C and C cancel. So what will get? 0. Similarly, if we add all these three, we get 0, same as for this and 0. And write the remaining elements as it is. Okay, write the same elements. Since here all elements are 0, right? So the value of determinant gets 0 itself. This is also the one of the properties. Okay, if all elements of a zeros, that means the value of determinant gets 0. Now see the next question. The exercise based upon logics, right? So you have to practice. 2, 3, 5, 7, 8, 9, 65, 75 or 86. As I said, the exercise is based upon properties as well as the logics, that which property can be applied in this question. So see, this one is maximum number. So now we have to think that which number should be multiplied by any column or row to get the third one as it is. Okay, so see C1, this is C1, C2 and C3. So if I write C1 plus 9 into C2, just think what will come. C1 means 2 plus 9 into 7. So what will come? 9 7 is 63 plus 2 65. So by using this property we will get here 65. Similarly next 9 into C2 plus add 3. So 3 plus 9 into 8, 72 and 3 75. Similarly next 9 9 81 or 5 86, and this column remains as it is, no change. Clear? And you can go for some other operations like C2 can be changed, or we can subtract, but we have to get what the simplest form, or we will try to get the same elements, right? So we find now these two columns C1 and C3 are identical, and as the property says, the value gets 0. Okay, so this is the question number 3rd. Same as, let's see question number 4. Now we'll solve one more question. So see, so first of all, result is what? 0. Now we will simplify this term first of all. So C1, C2 as it is. AB plus AC will come, BC plus AB, and CA plus BC. Right? We have simplified this term. Now we see that this is constant 1 1 1, and here is AB, BC, CA something coming. So if we operate what? C2 tends to C2 plus C3, because they are what? Like terms, similar terms. So what we will get? 1 1 1 as it is, C2 plus C3. So you will get AB plus BC plus CA. I am writing in order, same as here. If you add this AB, BC, CA, and next term AB, BC, CA will get, and the column 3rd as it is, AB plus AC, same as we will write here, these terms and this terms. Now in the next step, what we will do, see, all elements are same, I mean same terms, okay. So we will take what? The whole term AB plus BC plus CA, what? Common, as property states that we can take any term common if it is there, or if multiples is there. So AB plus BC plus CA taking common from column 2nd. So what we will get? 1 1 1, and this should be written outside. Okay, that K properties. Now 1 1 1, and here is 1 1 1. So what we will get in next step? Two columns are identical, and then the value of determinants gets 0. Right? So this is how that we have seen the uses of the properties. So I hope you will try some other questions. So today's homework is to solve the examples. There are some good examples, okay, asked in board exams also. And now we will solve the remaining questions and ask your doubts. Thank you so much.